Now, this particular problem here, they want us to differentiate the function. And in this case here, the easier way to do it is to use that extended power rule. Okay. Now, what that extended power rule says something like, for an easy example, would be let's say I had a function x to the fourth, and I took the derivative of it. I'll end up with 4x to the third. The extended power rule treats this as if it were a function and takes the derivative of x. So the derivative of x would just be 1, which is the same thing as 4x to the third. So here I would have a function. Here I have to take the derivative of this function here. And so I see this as an extended power rule of some type, where I use the power rule, then I take the derivative of what's on the inside. So I have k times g of x raised to the k minus 1 times the derivative of what's in here, which is just going to be g prime. So this is my original function here. Okay. So in this case here, my k is going to be 4, and my g of x is going to be what's on the inside. It's 8 minus 7. Okay, so my k is 4, my g of x is 8 minus 7. And so the g prime of x, is derivative of this, is just going to be 8. So when I find the derivative here, I'm just going to plug in. So that my derivative is going to be k is 4 times g of x, which is 8x minus 7 raised to the k minus 1, which is 4 minus 1, times the derivative of g of x, which is 8 here. And then I simplify it. And that gives me my answer.